Welcome to TechArt Corner New Studio. We are going to check how hard it is for a single Unreal Engine developer to record himself and then track, rotoscope and place inside of a 3D scene. Just wearing a costume like this one may not be enough to convince you that I am a news reporter, but hopefully enough of digital magic will be. I think the result is pretty promising. I really wanted to make such project from A to Z, including tracking in Blender, normal estimation, and placing footage in Unreal. And what I love about it the most is that I can change lighting in the 3D scene and the footage will behave just like some mesh that someone modeled. It's just amazing and you don't have to go through difficult compositing in DaVinci or some other software. I have some Unreal and Blender experience, but what I did here was completely out of my field of expertise. And what I think is quite important is that I used no paid tools at all. And we can put a little asterisk here, but I will explain it later. I'm going to show you the whole process, and I am not going to skip the parts when I struggled. I believe that this or similar pipelines may help a lot of you to produce your own mini VFX shots on low budget. I started with recording the footage and tracking. I didn't use any fancy lenses, but I did use 4K recording because for tracking, the more pixels I had, the easier it would be. And where I was recording, there was a plain wall with very little detail. So I printed out some tracking markers and they helped me a lot. I also wanted to have a floor on the recording as a reference point. So I used some red and green tape on it. The red worked way better. I overestimated my tracking capabilities, to be honest. I used way too little markers, especially on the wall, and I also made a pretty huge mistake. At the beginning, I wanted to point on the floor and to move camera up because when the camera was facing me, there would be no points of reference of where the floor is. So I wanted it to start at a very, very low angle. The issue is there was a huge motion blur. So if you are doing the same thing, remember to rotate camera slowly. Also, the other thing is that at the very beginning of the recording, I stuttered, and instead of creating a new recording or putting the camera down on the floor, we just waited 1, 2, 3 seconds and started again. And that means that now I had this very beginning that was important for me and a lot of wasted frames and then the footage I needed, but I would have to track all of them if I wanted to have a consistent camera solve. So it is quite fine if you are recording and you just want to keep going. But if you are doing that with tracking in mind, do not let that faulty take to be in the middle of the video. And that's it. So I ended up with a very imperfect solve, but it did work. I just narrowed the frame rate that I was working with, and I managed to have solve error of about 4 pixels, which is not perfect because ideally we would like to have less than 1 pixel, but in this case I was quite happy with 4. If I had anyone to assist me and to hold the camera for me, I would dress up again and I would make another video. But I knew that I wasn't going to meet anyone for a few days. I had my plans already and I just didn't want to postpone at all. I wanted to already start working on the video. So we have 4 pixels of error, camera maybe a little bit off in a few places, but I'm still quite happy with the result. And if you, like me, struggle with tracking for any reason, you can also try looking for some AI solutions. And I mean, literally running AI from GitHub on your machine. But if that is too hard, you could try Beeble. Beeble is one of those AI startups for VFX, and they do have such thing. But I wanted to do something using free tools and as little AI startups, so I just went with Blender anyway. Let's take a break from Unreal. Before we import our footage to the engine, we have to prepare it. The first step would be to get rid of the background behind me, and the second step would be to get PBR textures. We need at least base color and normal map, but if we are lucky, anything else that we can get is going to help us get better results. So let's start with background removal. I didn't record myself on green screen, and that meant I would have to go with rotoscoping. But I have no After Effects, I have no rotoscoping experience, and also it's very time consuming. So I knew I had to automate the process. And I started research, and I have good news for you. Rotoscoping is not that hard to automate. If you are already paying Adobe for Photoshop, you can do it all with built-in things, with built-in features. And if you want to batch like 2000 frames at once, you can use a free tool from Creative Twins website. And there is also a tutorial on YouTube. Also, if you are paying for DaVinci Studio license, you can use Magic Mask, and my guess is that there is some similar tool in After Effects. And even if it's not, they are competitors, so they will make a similar tool. But if you are going with free solutions, look for AI. There is a Track Anything repository on GitHub and also a SAM2 model released by Meta. If you focus on SAM2, it's great because it has a free demo that works in the browser. You can upload your video, and then you will get your video with some green screen behind your back, and then you can just Google how to get rid of that green screen. But if you're not going with this approach and you want to set up everything locally, just please keep in mind that it's getting easier and easier to make those tools, and GitHub is literally polluted with hundreds of them, and my bet is that a lot of them contain malicious code. So if you don't know what you're doing, please don't. And if you are downloading something from GitHub, please download some trusted repository. So you may be wondering, how did I finally achieve rotoscoping? I didn't really pick any of those solutions, and that is because I still had to do base color and normal map from the original footage, and the solution I used for that also contained rotoscoping. So keep watching. When I wanted to get those normal and other PBR textures, I started looking around, and it turns out this process is called normal estimation, and it is under heavy development. It is far from perfect. And if you look on the footage I provided, my skin is quite smooth, and that's one of the imperfections, but you can still see the features and you can distinguish shapes. So it's definitely getting better and better. And maybe in 2026, 2027, it will be uncomparable to what we have currently in July 25. I was looking for some GitHub projects, and I found Design, which yields really good results. What you have to do is to install Miniconda Python package manager and then follow their guide. And I wish the guide was more comprehensive to non-technical users, but what you are doing there basically is downloading the repository, then running provided command to install dependencies, and then you have to download weights from Google Drive and put them in desired folder. The dependencies are few gigabytes and weights are just about 5, maybe 600 megabytes. Not that bad. The thing is, the process didn't work for me. It's most likely because I started by downloading wrong Miniconda version and then the wrong Python version. I really don't know why, but yes, I did that. And then I installed dependencies, and I probably didn't clean the directory properly before retrying, so I was getting some errors in the code. And I thought that I am not going to spend too much time on that if there are other solutions. So I fall back to Switchlight. Some people have been using Switchlight for a year already, or maybe even longer, so there is a chance you have heard the name. It currently has a version 2.0, and the company and the website is called Beeble. I'm quite cautious about such things. Many of those startups rise and close, and also if you record tutorial on using that, it's going to be outdated fairly quickly. So that's the issue. But my approach was that I'm going to use them to get textures and the mask, and I am not going to use any other automation from them. So they do have tracking automation, and they also have plugin that can import the footage for you into Unreal or Blender. And I decided not to use it because I want to focus on the core principles, and I still wanted to learn something, right? And of course, to show it to you. So I went with Switchlight, but before I move on and tell you what I noticed, there is one more important thing. It's free. At least it's free right now. And if something is free, then you are the product. So make sure you read their privacy policy first. If I understand properly, they can use uploaded photos or videos to train their AI, and you may like it or not. The decision is up to you. But I believe it's pretty clear in the conditions, and they didn't try to hide it. So you can just comment the video if you disagree, but keep in mind, they will likely use your footage for AI training. And that's something that artists usually dislike. So back to Switchlight. It processed over 1600 frames for me, and I'm really happy it happened on an external machine. You can even have a potato rig, and it doesn't influence how the Beeble is processing your stuff. It's done remotely. It's great. I really like that it detected my resolution correctly, and it detected that I was using 29.99 frames per second. Then I had to wait about an hour, so I just made a very long coffee break. And finally, I was able to download all the frames separately. And I think that's the most important part. If you are able to access the frames as PNG sequence, this is what gives you the most control. The frames were in a bit lower resolution. I'm really happy that I used 4K footage, and that's probably why I still got frames that were bigger than Full HD. So it wasn't a bad thing for me, but I still dislike that I uploaded 4K, and what I got was like 2048 pixels on the long edge. I like, my guess is that they did that because if you use textures that have power of 2 dimensions, then this is a huge GPU optimization for a lot of processing. But I would still like to finally get a video that has the same resolution. So besides the frames, you also get MP4 files that are super lightweight. And it's great because if you try downloading all the frames from my project, it is going to be 12 gigabytes. And such single MP4 file can be 7, maybe 15, maybe 30 megabytes. It is way, way less. So I decided to go with MP4 files. I was uploading it to Engine. I didn't want to struggle with all those frames, and I wanted to make a quick test. And if it would work and look correctly, I would stay with it. If I had any issue, I would be able to fall back to the frames. The issue is that those MP4 files did not match my input frame rate. My input was 29.97 and it displayed it in my face. But those MP4 files that I downloaded were 29.0 and they didn't include the information. So I trusted them that the frame rate is the same. I did everything from A to Z, and I realized it when I was editing already rendered video. So honestly, please check it. Maybe they will see this video or they got reports from other users and they will fix it. But please make sure that your frame rate is right, because it's not gonna be in sync with audio. And if you want to overlay it over the original footage, it's not going to match. I used I just changed the video speed in Resolve to patch it quickly, but that's workaround. That's not a legitimate solution. So anyways, after those steps, I already had everything rotoscoped and I had the textures, so I was able to come back to Unreal. All right, we got the passes. So first we are going to import the camera and then we are going to import the passes to Unreal. So if you are in Blender and you already finished the tracking, you should have a lot of markers in the scene and you should have the camera movement solved. So when you play, the camera is moving. But if we try to export right now, it would not work on import. And that is because currently our motion is solved and is moving the camera using a constraint. So if you select the camera object and go to this constraints tab, there is a camera solver and we have to apply it. But if you do it, you will no longer have the constraint, right? So the best way to do it is to hit Shift D, duplicate our camera, and now constraint to F curve. And as you can see, we have lots of keyframes on each frame. And that's what we are going to export. Also, if you have some reference assets, that is great as well. So I'm going to select those two assets additionally, and then go to File, Export, and let's look for Universal Scene Description. Here in the settings, the most important thing is that we enable animation, otherwise the keyframes will not be exported. And I'm also going to export what I selected, so let's pick selection only. And this way we are, of course, not exporting two cameras by a mistake. In object types, let's go with the default, but if you changed anything, just make sure that meshes and cameras are enabled, and that looks to be all we need. If you are exporting to any other software, you can change the transformation settings, but here everything is fine. So let me call it tracking YT for YouTube. Export. Great, we should have the file, so let's move to Unreal. In Unreal, I suppose you already have plugins enabled, but if you don't, just search for USD and enable those three: USD Core, Importer, and Importer MDL integration. You can also try multi-user synchronization, but this is not going to be used by us today. Move to the top bar window, and there you can find a USD stage editor. It should pop on your screen. Let's go to File, Open, and let's find the file we created. That's the one. Let's open, and it already created something in our scene. That's our preview. But what is important for me is that we can change the start or end frame if you need to add some offsets. And also, we can already set our frames per second settings, and also here timecodes per second. Up axis is Z, that's coming from Blender, so this is correct. And if everything seems fine, go to Actions, Import, and then you can pick a folder for yourself. Let's go to Prototyping, and I have a folder called Comp Relighting. So hit OK. And this is another window where you can decide if you want to skip importing some assets. So if you selected two cameras by a mistake, you can skip one of them. You can also go through other asset settings and check what data you want to import. I'm going to go with the default. So let's import. Do I want to save? Yes, I want to save my changes into USD. All right. And now we got this new folder. The cool thing about it is that it already created a level sequence. I like to place them on the level. So let's do that. And let's double click to open it. And that makes our camera move. It's very little on the screen, so you may not see much, but if we select it, we are able to see the animation. So the animation is here. And if you applied your scale correctly to assets, you can treat them as reference points. For instance, here we have like 1.8 meter height of this cube and width as 40 centimeters. A good reference point. If you have some other assets on the level, you can try to match it. Right now, everything here is empty, so we are going to be eyeballing. I already had the camera, and I was really tempted to work on the environment, but it wasn't the time yet. I needed to make our camera see the footage that we prepared first. So when I started prototyping, I was just attaching a plane to camera, but I realized that thanks to the built-in media plate plugin, I already have something that I can use. If you enable engine and plugin content in content browser, you can browse through plugins and you can look for media plate blueprint that is attachable to cameras. It is made to work with a single media player and has some material that can carry out a green screen. So not exactly what I wanted because I'm going to go with few different media files and I had no green screen, but it is a good start. I didn't want to modify original files, so I created a copy of this blueprint and the material it uses, and I modified them myself. I have a very simple setup here. I changed material to masked, so it supports opacity masks, normal, and more. And then my pipeline was really simple and repetitive. First, drop MP4 into content browser. Then create media player and set it to run that MP4. Of course, if in the process you are asked if you want to create a texture source, do agree. Once we are done, you can drop the texture into the material and plug it in. So now the material is ready. The only thing is that it's not playing in the level sequence. So add a media track to the level sequence, then set the track to play your player, and then go to its properties and set media texture. After it is done, your texture is playing together with whole sequence. And if you missed anything, there is plenty of tutorials on running videos inside Unreal. Okay, so now, thanks to our texture passes and the material that we created, we can light the footage using lights in the scene. And it is exactly why we did it all. To be able to nail the lighting and match the footage with the environment. My face is a bit blurry, as I told you before, but the technology is getting better and we will have greater results. I also had some issues with white edges, and I tried playing with the threshold of the material, and it did actually help. It's not perfect, but it is good enough. Lastly, there was some point when everything was placed, and I created a simple environment scene based on old broadcast sample from Unreal 4. I really wanted to have some lamp model in the scene because in real life we are lit by physical objects. So if something shines lights on me in the scene, it should also be physical. It also helps to sell the effect. It makes you feel that something is real. But there was not so much space between me and the camera because it was recorded in my living room and it was only 2 or 3 meters. So I decided to go with something Mm, that's not too big. I found some softbox for free, and I've put it on the left side, so it wouldn't occlude the whole view, but it would be still visible there. And I rotated it so the bright part would be on the screen for a few seconds, so anyone would be 100% sure that this is a lamp. And the thing is that I have also put a separate light there, and I rotated it in a completely different direction to shine light on me, but it still does the illusion. Later, I also decided to add a little amount of glow and lens flare, but I believe I could have done it better in the post. Whew, almost done. The last step is to render, and that is when I noticed that even though I imported USD scene with correct frame rate and I had correct frame rate in level sequence, the sound didn't match the video. And that's the thing I told you already. I uploaded files to Beeple and it detected 29.97 frames per second, but exported 29.0. Had I noticed it, I would have used frames instead of MP4, or maybe use those frames to export my own MP4, but I was already so tired, I just decided to fix it in post. So if you are watching it and it feels a bit rough, keep in mind that it would be way smoother if that unhappy accident didn't happen. Anyways, I wonder what is your take on it? I'm a little concerned with privacy policy when using AI for normal estimation or rotoscoping, but I'm also extremely happy that those tools will make VFX more accessible for many small creators who don't have resources for proper recording environment, or maybe they do have resources, but they just don't have time. They have friends, they have family, and other hobbies. I, of course, still love practical effects, but being able to easily cut out yourself from footage without green screen and tedious rotoscoping is just great. Please leave the interesting part of doing VFX and take that repetitiveness from me. So yeah, that's it. And I hope you liked it. I'm probably not going to create an A to Z tutorial on what I did here, but I may record tutorials on some parts of this pipeline. So yeah,